Throughout this voyage, we're accompanied by our satellite, the Moon. There it is on your screen and, at the same time, outside your window. Your screen is a porthole on the Spaceship Earth. The Moon takes nearly a month to circle the Earth. Seen from the Earth, the Moon seems to follow roughly the same path as the Sun. It rises in the east and sets in the west like the Sun. But the Sun rises in the morning and sets in the evening because the Earth is turning, while the Sun remains firmly set in the center of the solar system. So every day towards noon, we see the Sun in the same part of the sky, to the south. Things are different with the Moon. The Moon revolves slowly around the Earth, and each day it changes position. Tomorrow at the same time, you won't see it in the same place as today. It will be 2 hands' breadths to the left. As it progresses on its orbit, the Moon lines up with distant planets, allowing us to locate them in the sky. Saturn, for example, at the other end of the solar system. Here's the Moon, and here a hand's breadth to the left is Saturn. If you take your bearings from Saturn, you can measure the daily displacement of the Moon. One evening, the Moon is to the right of Saturn. The next day, it will have moved to the left of Saturn. Each night, the Moon appears to have moved 2 hands left. And each night, the Moon passes by 50 minutes later than the night before. 50 minutes is the time the Moon takes to travel the width of 2 hands, that is, to appear where it was yesterday at the same time. Every evening, the Moon is different. It never stops changing. One day it's a small crescent, the next a slightly thicker crescent. A day later, it's even thicker. But why a crescent? In space, 1/2 of the Moon is always lit by the Sun. But from the Earth, we see the Moon in another perspective. For us, it edges a little farther from the Sun each day. When the Moon has moved to a position only slightly away from our view of the Sun, it appears only backlit, and we can only see a tiny part of its sunlit half, a crescent. The Sun has just set. It's there on the right, just below the horizon, and from there, it lights up the Moon. The crescent is still aimed towards the Sun, of course, as it's the Sun which lights it. Each day, the Moon moves a little farther from the Sun. So each day from the Earth, we see a larger part of its lit half. A crescent which grows daily and which will become a half moon. In its half-moon phase, the Moon overflies our orbit. It crosses the path the Earth has just taken. Every day, the Earth turns once. During this day, the Moon continues on its way, so we see it displaced to the left. It will reach yesterday's angle 50 minutes later. In crossing the Earth's orbit, the half-moon becomes a reference point which allows us to picture our own path. Normally, we can't really see where the Earth is going. But on the night of the half-moon, we can see where we've come from. Where you see the half-moon, that's where the Earth was 4 hours before. Look at your watch and look at the half-moon. Up there, at that point in the sky, is where you were 4 hours ago. And in 4 hours, the half-moon will have taken your place. It will be there where you're standing now. For once, as you look at the half-moon, you can imagine the invisible track that carries us once around the Sun every year. As the Moon moves on farther and farther, passing 50 minutes later every night, it finally appears not only at night, but also during the day. When it enters the second quarter of its orbit, it becomes so bright that it can be seen by day. in the afternoon in the southeast. Where does the moon come from? We don't really know. Perhaps in the beginning, when the primitive Earth was not yet compact enough and was spinning very, very fast, part of it came away and began to revolve around the Earth. But perhaps the moon came from a distant part of the solar system, passing too close to the Earth. It may have been captured by its pull and dragged into its orbit. Finally, there may have been a collision with an asteroid, with the debris condensing to form the moon we have today. A moon which accompanies us throughout our voyage around the sun. As we see the moon shift every evening, we can imagine its path around the Earth. We can imagine the space in which the moon moves around the Earth. And when the moon is 50 minutes late, there's a shift in time. So the same thing is happening in both space and time. During our journey, we'll see that space and time are very close cousins. We're here, hurtling along on our orbit at 107,000 kilometers per hour. In 2 months, we'll be here at the vernal point, meaning the point of spring. A point in space or a point in time?